Hello friends, welcome back to Ekeeda. As of now, in this chapter we have discussed about the phase diagrams and properties of the soils, and also we have seen some of the tests, how to determine them, and also we have seen the relationships between them also. As of from now, let us solve the some of the problems based on the theory, whatever we have discussed. At the starting, let us just solve the problems based on the formula oriented and then we'll go on to the conceptual wise. Okay, now let us start it. Okay, let us read this problem. Determine the water content of a soil sample from the data obtained below. Okay, generally, how you will find the water content? Water content is nothing but a weight of the water to the weight of the soil. Now, here what is given? They have given weight of the container 40 grams, weight of the container plus wet soil 100 grams, weight of container plus dry soil. They have given it as a 80 grams. So first we should know the formula of water content. So if I just express water content, that I can written as weight of the water divided by weight of the, it is not the soil, it is nothing but a solids. Or we can say this weight of the solids is nothing but a weight of the soil in which condition? In the dry condition. Why? Because in dry condition we will have only the solid particles and the air. Air doesn't have any mass. So if any soil is in the dry condition, then it is automatically represents that that is nothing but a weight of the solids. Now see the given data. First I want to find out the weight of the water. How can I find out? See here, weight of the container plus wet soil, weight of the container plus dry soil. If I subtract from one of these two, then what will get? We'll get nothing but a amount of water present in the soil sample. So what will be the amount of water in the soil sample? With wet sample 100 grams, with a dry sample 80 grams divided by whatever the weight of the solids. Now see these two. Weight of the container given, weight of the container plus dry soil. If I subtract these two, I'll get dry soil mass. Dry soil mass is nothing but a solids, weight of the solids. So divided by container plus dry soil 80 grams minus container weight is 40 grams. That will be equal to, here it is 20 grams divided by here it is 40 grams. Okay. And as both are same units, we can express this in terms of the 1 by 2. And if you want to express this in terms of the fraction, we will express it as 0.5. Suppose if you want to express this in terms of the percentage, then we will express this as a 50%. Just directly formula oriented question. Okay, let's move on. Let's see the second question. What is the given? A soil is having bulk density of 1.8 gram per cc at 5% water content. What will be the bulk density of same soil at 10% water content? So if by understanding this question, what they are saying, there is a soil sample and it is observed that if the water content is 5%, then what they have said, the bulk density is obtained as 1.80 gram per cc. Suppose if you are adding some water, because of that, if your water content is raised to 10%, what will be your bulk density? So how can I find out? So there are two things to solve any problem. First thing is that either you can rely entirely on the formula oriented approach. So even though if you definitely rely on the formula oriented approach, then 99% of the times we may correct. But there are some problems, if you strictly by heart the formula, then we may go wrong. And if you go in another way, I don't want to rely in the formula, I want to rely in the concept. So if you want to rely in the concept for solving this simple problem, we may take either 5 to 6 minutes of the time, right? So what is the difference? If you completely rely on this concept, you're wasting our time. If you completely rely on the formula orientation, then we are not accurate. That means there may be a possibility that we may go with the negative marking. So you have to by heart the formula, as well as you also should know how it is obtained, or how can you find a particular quantity in a conceptual manner. So if you can by heart, or if you think in these two ways, then solving a problem is easy. With less time we can solve it with much accuracy. Why? Because every time it is not mandatory that the data will be given as same. They may give some additional data, they may confuse a little bit. So just understand the concept as well as the formula so that we can get the accurate solution. So here, and they are saying it is a particular sample. And now my question is, will the void ratio will change or constant? What is mean a void ratio? It is nothing but a volume of voids to the volume of solids. Voids are not changing, solids are not changing, then I can say, unless and otherwise we are not adding any additional soil and all. So here we can say that our E value is equal to constant. That means volume is not changing at all. Suppose, let us forget about, suppose if I consider the same soil sample in a dry condition, what do you think it will be? I can say that my gamma D is also constant. Why I am talking about dry condition? In dry condition, we do have only weight due to the solid particles. Solid particles are not changing and volume is also not changing. Then we can say gamma D is also equal to constant. Now, let us think about the relationship between these two. Is there any relationship between the dry density and the bulk density? Then we may obtain it like dry density that will be equal to bulk density divided by 1 plus W. From the present condition, we have observed that your gamma D is constant. Then what we can say? I can say that my bulk density is directly proportional to 1 plus W, water content. So just apply in the present condition. Here I'll say it is like gamma 1 divided by gamma 2. That will be equal to 1 plus W1 divided by 1 plus W2. Now here let us see it is the first condition. Gamma 1 1.80, W1 5%. If W2 is 10%, what will be your gamma 2? Substitute the values here. Gamma 1, it is given it as a 1.80. Gamma 2 we have to obtain, that will be equal to water content percent. So here we have to substitute in the decimal. So in the present, it's 0.05. Why? Because 5% divided by 1 plus 10% is given, that means 0.1. Then if you solve this, we will get at 10% of the water content, the bulk density is obtained is equal to 1.88 gram per cc. It is obvious that if you are adding the water, why? Because as the whole water content will increase, if somehow if water is added to the soil sample, then only water content will increase, right? If the water is added additionally, weight will also increase. If weight is increased, then our bulk density will also increase. But our dry density will remain the constant. Why? Because it is consist of only solid particles. Next. See the question. What is given data? For a given soil sample, if true and apparent specific gravities are 2.7 and 2 respectively, determine the void ratio of soil sample. Then, how can we find out? right? Now, let's just say what is the true? True is nothing but they are talking about the z value. How much they are given? They are given it is a 2.70. What about apparent specific gravity? Apparent specific gravity is nothing but I can say it as a Cm that will be is equal to 2. So apparent is depending upon the type of the soil condition. That means either it may be in dry condition or whether it may be in the saturated condition or we can say it in the bulk manner. Bulk means nothing but a partially saturated soil also. So what will be the relationship? Suppose if they given Z and Zm, how can I find out the void ratio of the sample? Isn't it? So here the first thing we have to understand is that did they mention anything that whether it is a saturated soil, dry soil, or partially saturated soil? Why? Because if it is a dry soil, then what will consider? Will consider degree of saturation is equal to 0. If it is completely saturated, then we can say it as a degree of saturation equal to 1 or 100%. If it is partially saturated, then we have to mention any some value like how much percentage of the voids are filled with the water. Did they mention anything in the question? No. That means it is insufficient data. So let us say that it is a for a saturated soil sample. So for saturated sample our S equal to 1. Then how should I express my operant specific gravity? Then I will express this in terms of the gamma saturation divided by gamma W. That is given as 2. Then what is the relationship between gamma sat and what is the absolutely at the end of the day we have to find out the void ratio. So what is the relationship between those two? Then I can say that gamma saturation that will be equal to gamma W into G plus SC divided by 1 plus. So we have already seen the formula, right? We have given gamma sat divided by gamma W value 2. G value is given as 2.70. Then what will be this S value? 1. Then substitute in the relation 2 that will be equal to 2.7 into sorry, G plus SC, right? So 2.70 plus what about the saturation? As it is completely saturation is 1 into E divided by 1 plus E. That implies we can obtain, if we solve this, then we get our void ratio as equal to 0.7. Understand? Okay. Move on to the next. Okay, let's just read the question. What they've given. For a soil sample, if true specific gravity is 2.5 and void ratio is 1, and determine the ratio of, and see here you can observe. So if they are given our void ratio, if specific gravity is given as 2.5 and void ratio is equal to 1, then they are asking about the ratio of these two, right? So if I know Z and E, how can I find out the gamma saturation? Then I can say it is in terms of, if you remember the formula, we can say G plus SC into gamma W divided by 1 plus E, right? Then, however, the gamma submerged. So there are two ways to find out, either by directly by adding the formula gamma submerged, then we can obtain the value. Otherwise, gamma submerged, we can see it as a gamma saturation minus gamma W. So here I know all the values. As it is saturated, G value is 2.5. As it is saturated, S value is 1. Y ratio is also given as 1. So 1 plus 1 into gamma W. Right? Now, if we solve this, let us say that your gamma W you are considering in gram per cc. right? We all know the weight density is water weight density is nothing but a 1000 kg per meter cube. As y to increase the value, let us consider in gram per cc. That means if you are taking 1 centimeter cube of volume and it is filled with water, then it is having a weight of one mass of 1 gram. So if I solve this, then I'll get is around 1.75. That will be equal to 1.75 minus 1. That will be equal to 0.75. Then what will be the answer? Gamma saturation divided by gamma submerged. That will be equal to 1.75 divided by 0.75. So if we solve this, we will get it as around 2.33. Right? So here if you observe this, just all these things are formula oriented only. Why? Because even in exams also, if you understand it, like 60% to 70% of the questions are formula oriented. But what is the problem? Why students are not able to solving it? Because if it is a only particular subject, even if I give you after 1 month, you may be able to solve. But as you are studying n number of subjects, our brain may not recollect immediately, or it may forget some of the formulae. So to avoid that, we have to practice so many times. Like if you can practice 2 to 3 or 3 to 4 times, then things will be remembered permanently. Permanently means not until your lifetime, but up to some extent of the time. If you don't revise it with the time process, whatever I was studied, that is also. So you should always keep refer the formula or studying the formula whenever you are having the free time or whenever you are traveling, so that you will be uh, permanently remember the formulas and you can solve the problems easily. Right? Now move on to the next problem. What is given? Determine the change in volume of soil sample at void ratios 1 and 0.6. Here, if you see this, they don't need what is the original volume under. What they need, if let us say that at some instant of the time, void ratio is obtained to be 1. At some another instant, it is obtained at 0.6. So, if void ratio is changed from 1 to 0.6, then what will be the change in volume? Right? Now, if you observe here, void ratio is nothing but a volume of voids to the volume of solids. Right? Suppose if I am talking about the particular soil, I cannot change the volume of solids unless and otherwise you are removing it or so. How void ratio is decreasing? That means we are doing some stabilization. That means either we are doing compaction. So while doing compaction, our void ratio will decrease. That means volume of voids are decreasing. As volume of voids are decreasing, your void ratio is decreasing. So if void ratio is changed to 0.6, what is the change in volume? Change in volume is only due to the decrease in the volume of voids. Right? Now, how can we obtain? From the previous case, we know that volume is directly proportional to the void ratio. So how can I express it? I can say it as volume is directly proportional to 1 plus C. That implies if I use the remove the proportionality, I can say V1 by V2, that will be equal to 1 plus C1 by 1 plus E2. So what will be the ratio? 1 plus 1 divided by 1 plus 0.6. So from this we can say V1 that will be is equal to 1.25 times V2 if you solve this. But what I need? All I need is the change in volume. So what is the change in volume? So the change in volume, delta V, final minus initial, right? Or initial minus final, depending upon which one is the larger. As V1 is larger, I can say V1 minus V2. That will be equal to the. So here, how can I express this value? Here it will be 1.25 times V2 minus V2. So if I am solving this 0.25 times V2. Now if we understand here, are we getting any percentage or if you are getting any value? So even you are saying change in value, this again in terms of the volume at the second case. Is there any specifically you are getting like change in volume is 10 centimeter cube, 10 cube and all? No. Then here we will find out in terms of the percentage. So what is the change in volume percentage then? That will be equal to the change in volume to the original volume, right? What is the change in volume? 0.25 divided by V2. What is the original volume? V1. So V1 we are expressing in terms of V2, that is nothing but a 1.25 V2. So if we are solving this, we will get this value around the 20%. Suppose if they are given V1 and V2, or if I are given any one of those, then we can have found the other value, and based on that we can find out the change in volume. But here, as they haven't mentioned anything, we are expressing this in terms of the percentage. Okay. In the next video, we will solve some extra problems. Thank you.